your diagrams and wanting to scream.
You decided to give us another day.
What's the first time
Can you give us another day for this, please?
So,
What
the
the heck?
first thing up at the top, in big bold letters, it says clearly label the following: object, image, image distance, focal point, and indicate the scale. I was appalled at the number of you that came in and gave me some random lines with nothing labeled and said, "Is this good?"
Oh, to be fair, it wasn't bolded.
Oh yeah.
I can't read. I can't read. Yo. I was just joking.
We haven't gotten to that part.
Okay? The whole point of this is that you are graphically determining what is happening, where you actually form the image. Now, let me go through some of kind of the more difficult ones, like number 2, for example. Okay? So on number 2, it's a diverging lens. So start with this idea. So a diverging lens is the same thing as concave. So, again, choose the scale. Like when I did number 2, I let 1 centimeter on that equal 5 centimeters. Like on my drawing, I let 1 centimeter that I draw equal 5 centimeters on that. Okay? I don't care what the scale is. Make sure I can clearly see it. You might even box that in so I don't have to sort through random chicken scratch and try and figure out what that is. So, candle is placed 20 centimeters in front of my diverging lens with the focal length of 10. Okay, so I'm going to come out here and go, okay, there's my focal point, okay, and then out here I've got my object, which in this case is a candle, whatever that is, okay? So, here's the story. You want to start that image where the base of the candle, or the wax end of the candle, as somebody put it, is in the middle and on line with that primary optical axis, which is that center line that goes through it. Okay? So draw that line right through the middle of the lens. Whether that's a mirror, whether that's a lens, doesn't make any difference. Always draw one horizontal line that goes right through the middle. Start with that. And then you put the object on top of that. Okay? Now, I always put my objects off to the left. Okay? That is not a rule. That's just how I always do it, because I always think better like left to right. If you want to put them on the right side and do that, that's cool. Okay? I think you're weird, but if that works for you, so be it. Okay? I always just put mine off to the left. So, here's my object. Clearly labeled. Oh, there's my object. Okay? So, when this light comes in here, I'm going to draw one parallel with that primary axis. It's going to hit this lens, and then it's going to get spread out like this. So this ray is going to try and go through that focal point.
Right.
Okay? So the reason that I draw that as a dashed line is because that's in the opposite direction that the light is actually going. So what's happening physically is that that light is hitting the lens. That's the direction the light is going. It's going to go through there. But some of that light gets refracted back in the opposite direction.
That's what Will said.
Okay? So that's why that's coming back like this. Now, I've got a focal point on the other side of this thing. Okay, I have 2 focal points. It's symmetrical, one on both sides. So then you take the other one and go, okay, hey, that's going to try and go through that focal point on the other side.
Oh.
Okay? Right? So that's going to try and go through there like that. But that basically is going to get refracted back along those same lines. So at this point, I have 2 things that have potentially defined where my image is going to be. Ideally, you would have a third one that would confirm that idea. So if you take this other one and you try and take it through this primary axis and just go through like that, okay, that's how you can get, well, I screwed that up, but that's how you're going to get that third point. So here's what you know, is that this image, number one, is going to be upright, okay? Because the only way that I could produce an inverted image of this is if it was somewhere like down over here. That's the only way I could produce an inverted image. And that won't work because these light rays are being spread apart. It's going to be a virtual image because of the fact that if I put a screen here, the screen would effectively block the light from going through it. So if I put a screen there, I can't make the image because the screen's going to block the light. That's how I know I could not make this a real image, because the screen would interfere with the path of the light. Okay? Now, mathematically, the light is being diverged. So what's the sign of your focal length? Negative. Is your object distance ever negative? No. Your object distance is always positive. The only two that can possibly be negative are your image distance and your focal length. Okay? Those are the only two. So, the idea here being is that you're going to draw this line. You're going to measure that based upon your scale. Okay? Now, I'm going to have a hard time believing that all of your measurements here were the exact values that you would get mathematically. It's like every one of your drawn values were the exact same numbers that you got when you calculated them. No. Not buying it. Okay? The whole idea was that you're using this, and then you figure out the math later on. Okay, so this is one that's a little bit more difficult. Now, anytime you have a mirror, doesn't make any difference. Convex, and this is the whole point of the lab today. Whenever you have a mirror, what we'll do is like a concave one first.
Yes.
Okay?
Here we go.
So, I don't care where the image is. Let's say here's the candle. Here's the first thing that I do with every mirror drawing. The first step I always do. I take a line and I go from the candle or whatever that is to the middle.
Okay.
And then whatever this is like 3 squares, I'm going to count 3 squares, and then I'm going to draw another line like this so that it's symmetrical.
Okay.
And then I take another line and take it up like this. Okay, it's the first thing I do. First thing I do. So with mirrors, there's only two options. Either that image is somewhere in here and it's inverted, or it's somewhere out there and it's upright. Okay, those are the only two possible locations you could have for a mirror. Somewhere over here in inverted, somewhere up there and upright. Now, if it's in here, and this is what you're going to do in the lab today, this would be a real image because that light is bouncing off the mirror and it's forming an image here. That's something that I can project onto a screen. Okay? This is something that you're going to do in the lab today. You're going to take a concave mirror like this, and you're going to make it project off of a mirror, and you're going to put it onto a screen. And you can bring that into focus. If it's somewhere back here, I can't project something that's on the other side. But this is where you have to understand like the biology side of this. So when you look in a mirror, you're getting ready in the morning and you look in a mirror, and you see yourself, if you think about it, this gets weird. If you look at that mirror image, it looks like you're on the opposite side of it. It's like you're behind the glass.
Yeah.
And it's like, oh man, that looks weird. You're not there, but it looks that way. So when you have a concave mirror, okay, like this, pretty shallow, and you bring that in really close, okay, and I look at my eye, All right, so here I am looking at my eye. So to me, it looks like my eye is on the other side of that, okay? Which gets really weird because I'm looking at this going, ah, cool, right? And it looks like my eye's on the other side. But if I flip it over, okay, and I make it that convex, so if you look at that, no matter where I put that convex side, no matter what I do, the image never flips over. So this is a simple way to tell if you have a concave mirror or a convex mirror. If you look at it and you only see an upright image, you're looking at the convex side of it. If you could produce an upright image and then an inverted image, because if you look at this now, I'm like upside down, okay? Well, that means you're looking at the concave side of it. That's the easiest way to do it. Convex only produces one type of image, and that's going to be back over there on that other side. So concave can do both. Concave is unique because it can produce a real image and it can produce a virtual image. So this is why I staggered these like I did. So on number 3, you have a concave mirror. On number 4, you also have a concave mirror. In both 3 and 4, they're concave mirrors. So what you should see on number 3, that concave mirror is producing an image on the other side. So what's happening is that your eye is here. And your eye is taking that light ray that bounces off, and your mind and your eye is telling you that it looks like it's on the other side, okay? And that's why it's a virtual image that's on the other side, but it's upright. Now, you can also have a concave mirror, like for example then on number 4. So on number 4, you're going to get an image that's pretty small. So on number 4, you're producing that image here. So on mirrors, you only have one of 2 options. No matter the type of mirror, it's either on the side of the mirror, and it's in this triangle right here, or it's on the other side of the mirror, and it's in that region. So it's either upright or it's inverted, depending upon which side of the mirror that you're on. But that's why I said the first thing that you do in today's lab is nothing but mirrors. When you get that mirror concave, convex, doesn't make any difference. First thing that you do is you draw a symmetrical line. And it's either here or on the other side. Those are your only 2 options. Right away, you've eliminated this down to a 50-50 shot. Okay? Those are your only 2 options that you have. Okay. So when you get to number 5, let's talk about number 5. So on number 5, you have a convex mirror. There's your primary axis. And you've got a person riding a bicycle. Okay? So again, I'm going to come in here. I'm going to do this. Do that. I'm going to do that. Okay? First thing I'm going to do, make it symmetrical. I'm either here or I'm there. Now, after a while, you just know with convex lenses, the only potential way you can make a convex lens is to have that image up there. It's always going to be on the back side. It's always going to be on the back side, and it's always going to be small. So with this one, you've got a focal length out here. So if you draw one parallel with this, and hits that, and you take that one through that focal length on the other side, right away, there's at least 2 lines that define where the image is going to be. There you go. The third one is just a confirmation of what that is. Okay? So, the other thing about convex lenses, what's the sign of the focal length?
Negative. Yeah, wait, negative.
Convex mirror.
Negative.
What's the sign of the focal length? Always?
No. Negative. Well, they take people apart.
It's always negative. Convex lenses are always negative. Okay,
Oh,
in
it's
terms of the focal length.
inverted.
Because the light hits and it bounces off
Yeah.
and it spreads apart. Now, are concave lenses focal lengths always positive or negative? Or does it depend?
Concave lens, always negative.
Excuse me, concave mirror.
Concave mirror.
Oh, well, there you go.
My bad, my bad, my bad. Concave mirrors are always
Positive.
positive.
Is the
It
great
doesn't
people-
make any difference where you have it in terms of the focal length, okay? So concave mirrors always have, so Olivia Pruitt, here's a little summary for you, okay? So if you have concave lenses, okay, which are like this, what's the sign of the focal length?
Come back.
Positive or negative?
Positive, negative,
Concave lenses
Wait a minute.
always have a negative focal length, okay?
Wait.
But concave mirrors
What's upright?
always have
Do tomorrow.
a positive focal length, okay? So concave lenses, negative focal length. Concave mirrors, positive. Now in contrast to that, if you have a convex lens, what's going to happen in terms of your focal length? That's going to be positive because it brings them together. So concave lenses, negative. Convex lenses, focal length is going to be positive. Now, if you have a convex mirror, the light's always going to hit and bounce away from that. So that's always going to have a focal length that's negative. Okay? So this is why you can't say, oh, if it's concave, the focal length is always positive. Okay? You can't do that. You have to look at it in terms of, well, what are you talking about? Are you talking about lenses or are you talking about mirrors? Okay? But this is why, and to a certain extent, this just comes with experience. Going, oh, okay, right. This is what the light's going to do. That's going to be positive, negative, however that plays out. If I were you all, and by the way, the test over all of this is going to be next Tuesday, okay? Next Tuesday. If I were you all and I was getting ready for this test, I would make index cards. I'd say, here's a concave lens, here's a convex, and I would do the diagram. I would say, okay, this is what these things look like, okay? And this just has to become repetition. Now, the good news is we've got basically 3 days of labs, okay, with this. So today's lab, this gives you some idea. So today's lab is going to be on mirrors. Tomorrow's lab is going to be on lenses. And Wednesday is going to be like a work day. So for those of you that have had me, this is the only time you will ever get like a work day to get all of this done. So I'm going to introduce the mirror lab today. I'm going to introduce the lens lab tomorrow. So I do this to kind of give you a break so that it's not horribly intensive homework outside of class. Elliot?
So the work day is just for both the labs.
Yes, the work day is for both labs.
Is there any other homework?
No. So basically, I'm going to give you lab today. I'm going to give you lab tomorrow. You have Wednesday as a work day. Latest I want everything to do is obviously Thursday. If you get the stuff done ahead of time and want to hand it in, you can. But so, mirrors today, lenses tomorrow, work day Wednesday. And I have never given you a work day.
Nope.
Okay? So accept it as a gift. Okay? Accept it as a gift. All right, so let me give you an idea of some of your answers. Okay? So once you do the math, right? So let me give you an idea of what the answers should be. So these are the image distance, like down here, 1 and 2 and 3, 4, and 5. Okay? Now, I'm not telling you positive or negative. I'm just telling you what they should be. Okay? So on number 1, on that image distance, that should be around 15. The image distance on number 2 should be between 5 and 10. The answer to number 3 should be around 40. Your answer to number 4, and these are in centimeters, by the way. Your answer to number 4 should be around 30. Your answer to number 5 in meters would make a horrible GPA. All right?
You know what they say, these get the green.
On the next set, 1 through 5, these are all mathematical, but you do need to make a sketch. You need to make a sketch where you label the object in the image. If you want to label the focal points, that's fine. Okay? So, label the object and the image. So, because if your magnification is right, probably everything else is right. So on number 1,
I wrote it on the wrong one. I mean,
the
those
magnification
should
should
be
be
around
around 1.
4
On number
centimeters
2, the magnification is around 0.6. The magnification on number 3 is also around 0.6. On number 4, that magnification would make an GPA. Okay, I said And on number 5, that would make an even worse GPA than number 4. But more than 1. So your magnifications on 4 and 5 are both bigger than 1.
Wait, this is magnification. Oh.
You okay with me putting S on one side for the labels?
1 and 2.
No, he's not. He's not.
You are
He's
gonna write out
not.
object in it.
Yes.
Yes.
Close to 1 and then place.
Yes.
You wrote
It
it
doesn't
down.
say anything. It says in big bold letters.
Some of them are
Like
like
that.
Yeah.
So is the object length, so that's what the object will be. I mean,
We have inverted images below the axis.
hey, I'm gonna take it from the
Yes.
guy who hasn't finished his homework, by the way.
Yeah.
Right, I was busy.
Wait, I have a question.
Michael, I had the same weekend as you.
No, you didn't have work instructions.
This is like,
On
I had the
these,
same
you
weekend.
remember when you got a 4 and 5?
this was the one with the fish tank and everything. Where it's air and then water.
Yeah, and then it's just
How did you know that this perfect, like the up and down line was line of?
All right, Mara, stop you on the camera.